In Lesson 67, Paul introduced us to the Pico W's second core and the concept of threading. Our assignment was to create a MicroPython program that would continuously cycle a servo motor back and forth from 0 to 180 degrees and back, while at the same time blinking a red LED when the servo angle was increasing and blinking a green LED when the servo angle was decreasing. This program requires the servo logic to be on one core and the LED logic to be on the other core. It also requires a color parameter to be shared between the two routines to control which LED should blink. Prompted by the previous few lessons on classes and libraries, this program interacts with the LEDs and the servo using the BK's LED and BK's servos classes, which are stored in the BK's classes file in the lib folder on the Pico W. Let's start with a look at BK's classes. These two classes are stored in the BK's classes.py file in the Pico W lib folder. Here we see the BK's LED class. The init method creates LEDs from the user-supplied GPIO pin number. The user can then turn each LED on or off by calling the on or off method. There's also a blink method which will blink the LED a user-specified number of times with a user-specified pause between on and off. Here we see the BK's servos class. The init method creates servos from the user-supplied GPIO pin number, and the user can then set the servo to any degree between 0 and 180 degrees with a simple call like servo.degree x for x degrees. The main program starts by loading the LED and servo classes from the class library. We load sleep as usual and _thread so that we can use the second core. Next, we declare the GPIO pins for the LEDs and the servo. Now that we know the GPIO pins, we can call BK's LED and BK's servos to create those objects. Here we declare the variable that will control which LED is blinking. It's initially set to none. Here we define the blink function. Later in the program on line 34, the blink function will be started on the second core. The blink routine contains a while true loop, so once it starts to run, it will not stop. But because it's running on the second core, this won't interfere with the operation of the servo. Also, the blink color variable is initially set to none, so we don't see any blinking. But eventually, blink color takes on a value of red or green, and we can observe the LEDs blinking. The _thread.start statement on line 34 calls the blink function and starts it running on the second core. The remainder of the program contains two for loops. The first one sets the blink color variable to red and drives the servo from 0 degrees to 180 degrees in 15-degree steps, with a brief sleep between steps. The second loop sets blink color to green and drives the servo back to 0 degrees, again with a brief sleep between steps. Remember that the blink routine is already running in an infinite loop on the second core. Once it receives a valid blink color, the blinking will become visible. And here's how it looks. Well, that's it for this assignment. Any and all comments are welcome. Don't forget to like or dislike the video before you go. And feel free to subscribe. Don't forget the notification bell. We'll talk to you next time.